This video is for section 5.4. Our objectives in this section are to factor a trinomial whose leading coefficient is 1 and factor a trinomial whose leading coefficient is not 1. Trinomial means that it has three terms. And so what these trinomials are going to look like is this going to be x squared plus bx plus c. Leading coefficient is 1 means that there's no number in front of x squared. So what this means for when it's factored is it's going to factor into two sets of parentheses, and you're going to enter x as the first term in each. You want to think about this as being backwards FOIL. So each factor is going to be x plus or minus a number, we'll fill in later, and then x plus or minus a number. So that when I do the f part of FOIL, I get x times x, which is x squared. Now, for the numbers, what you're going to do is find a pair of numbers, so two numbers, that multiply to c and add to b. Where c is the constant, the number by itself, b is the number in front of x. And this is a little picture that's in the book that I kind of like for illustrating this. We have x plus box times x plus another box, not necessarily the same. And when we do FOIL on this, we get x squared plus bx plus c. The b comes from combining the outside and the inside terms. So the outside is going to be something times x. The inside is going to be something times x. Add those two together and we get bx. So the bx here is the sum of o plus I. And then the c is the last from FOIL. So that would be the box times the box. The x squared comes from the f of FOIL. And then lastly, you'll see in the homework one of the answer choices will be that the trinomial is prime. What that means is that it can't be factored. So if it is not possible to factor something, then we say that it is prime. So we're going to start by looking at example 1. It says to factor x squared plus 5x plus 6. So our process for this is to start with the c, the number by itself, and think about pairs of numbers that multiply to equal that number. So 6 could be 2 times 3, or it could be 6 times 1. Now, what I need to look for is which of these pairs of numbers add to 5. 2 plus 3 is 5, 6 plus 1 is 7. So the answer is 2 plus 3. So when I set up my parentheses, it's going to be x, and then plus 2, plus 3, or I could write the 3 first. It doesn't matter. So what I can do to check this is I can use FOIL. So if I FOIL this out, I get x squared plus 3x plus 2x plus 6. And when I combine the two terms in the middle, I get x squared plus 5x plus 6, which is in fact my original problem. So it checks out. So this is the answer. What you should do next is checkpoint problem number 1. Do this in your notes, check your answer with the notes that are posted, and then you can move on with the rest of the video. Next, we're going to look at example 2. This is pretty similar. We're going to start by looking for numbers that multiply to 24. So 24 could be 24 times 1. It could be 12 times 2. It could be 8 times 3. Or it could be 6 times 4. So now what I'm looking for is the pair that adds to 14, and then we'll talk about the signs in a minute. So which of these pairs add to 14? Well, that would be 12 plus 2 is 14. Now, what you notice here is that I have this negative sign. It's actually negative 14. And then I have positive 24. So what that means is that the two numbers multiply to a positive number, but they add to a negative number. Now, if they multiply to a positive number, that means that the numbers have the same sign. So they're either both positive or both negative. They can't both be positive, though, if they add to a negative number, because you can't add two positive numbers together and get a negative number. It would just be a bigger positive number. So what this means is that both numbers must be negative. So in my parentheses, I'm going to have minus 12 and minus 2, whichever order you want to put them in. And then again, I can check this using FOIL. I get x squared minus 2x minus 12x. Negative 12 times negative 2 is plus 24. And then when I combine the two terms in the middle, it's minus 14x. So I get what I started with, and it checks out. So this is the answer. Next, you should do checkpoint problem number 2. Do this in your notes, check your answer, and then move on with the rest of the video. The last example that we're going to do in this video is example 3. You notice that this example uses y instead of x, and it's the same thing, it's just a different variable. So, you know, when you're doing these on the homework, you want to be careful of making sure that the variable is actually x, and don't just type x in for each problem, because it is going to mark it wrong if you use the wrong variable. So for this one, we're going to start by looking for numbers that multiply to 60, and then we'll talk about the signs. So multiply to 60 could be 60 times 1, 30 times 2, 20 times 3, 15 times 4, 12 times 5, or 10 times 6. 60 is not divisible by 7 or 8 or 9. And then that brings us back to 10. So those are the possible pairs. What I'm looking for here is I'm looking for two numbers that multiply to negative 60. So they multiply to a negative number. Then that means that one must be positive and one must be negative. So in my parentheses, I'm going to have 1 plus one of the numbers and 1 minus one of the numbers. Now, you have to make sure that you're putting the right numbers in the right spaces here. The right number has to be with the plus sign. There's only one way that it should work out. Whoops, and I made the mistake that I told you not to do, which is use x instead of y. So let me fix that real quick. It's a habit, I know. So y. So I have to make sure I get the right numbers with the right signs. So looking at my pairs here, what I'm looking for is the pair that when you make one of them negative and add it to the other, it equals 7. Or the other way to say that is they subtract to 7. And so if I look at these possibilities, the one that subtracts to 7 is 12 and 5. So subtract to 7. So that means 12 and 5 is my correct pair. However, I want to make sure I get the signs right so that it's positive 7. So in order to get positive 7, I need positive 12 and minus 5. 12 minus 5 is 7. If I put negative 12 plus 5, that would be negative 7, and so that wouldn't be right. So the 12 has to go with the positive, the 5 has to go with the negative. And then again, I can check this using FOIL. I get y squared minus 5y plus 12y minus 60. And combine the two terms in the middle, that's plus 7y minus 60, and so that checks out. So this is my answer. So next you should do checkpoint problem number 3. Do this in your notes, check your answer, and then you can move on to the homework.